I'm Anil Kumar, and in this video we'll try to understand how to sketch reciprocal of primary trigonometric ratios. The question here is sketch graph of f of x equals to 2 over 3 secant 3x minus 5 pi by 2 minus 2. You can pause the video, sketch your graph, and then check with my answer. Now, whenever we have an equation like this, it could be written as in the form of the primary trigonometric ratio. We could write this as 2 over 3. Secant is 1 over cos, right? So we can write this as 1 over cos of. It's good to factor 3 so that we clearly know what is our horizontal translation. So we get 3 here, x minus 5 pi by 6. So that becomes secant 3x minus 5 pi by 2, and then we have minus 2, the vertical translation 2 units down. So that is how our function is. Now, in this particular case, what we should do is, we should first sketch the cosine function, then find reciprocal of it, and then we can do vertical stretch, in this case a compression of 2 over 3, and translation by 2 units down. So these are the steps to be followed. Now if you have cos 3 x minus 5 pi by 6, what is the time period? So let us calculate the time period for this. So we have time period of 2 pi divided by 3, right? So that becomes the time period 2 pi by 3. And phase shift for us is 5 pi by 6 to the right? I can think about 2 pi by 3, since phase shift is in pi by 6, as equal to 4 pi by 6, right? That will give you an idea that, after the first cycle, the time period, this really starts much later. Since we have pi by 6 as our basic unit, it's a good idea to take a scale which is pi by 6 units each horizontally, right? Vertically, we have a compression of 2 over 3. That means we should take one division as 1/3. So we'll have one like this. Do you understand? Then 3 small divisions will make one big division. Do you understand? So each is 1/3. 1/3, 2/3, 3/3 means 1. So that scale will really help us to sketch this particular graph. So first thing which you should consider is a proper scale whenever you have to sketch something like this which involves a lot of fractions. Okay, so the vertical axis y or f of x for us is, each unit is 1/3. Now let's see where is 5 pi by 6, since the cosine function really starts from there. So we have 1 pi by 6, 2, 3, 4. Actually that's the wave. 5 pi by 6 is here. So the function starts from here. This is 5 pi by 6. Do you see that? 5 pi by 6. And the time period is 4 pi by 6. So if it starts here, it ends at 1, 2, 3, 4 there. So this is one wave for us. So we'll actually sketch one wave and then we can repeat it. That's the whole idea. I hope you appreciate it. For a cosine function, approximately, let me sketch one here. We are trying to sketch something like this, right? For a cosine function, where this is one time period, correct? This is one time period. In our case, the time period is 4 pi by 6. It's good to count by pi by 6 since that is our phase shift. So what we have decided is that from here we'll have one wave which starts here, ends that place. Perfect. And starting point for cos is 1. And then every quarter, do you see that these points are quarters? So this is t by 4. This is 2t by 4. 3t by 4 and 4t by 4. That is how it is. So every quarter it is 1, 0, minus 1. Correct? So first, next quarter 0. next quarter minus 1. Do you see that? And then we have 0, and then we have 1. So even without doing any calculations, I can actually get my cosine graph with these points. Now let me just join them, right? We know it repeats, so let me just join them with the help of a good cosine graph. I hope you appreciate how we have drawn this, right? So we get one cosine function, which is this one. Now the whole idea is, we can repeat it, right? So repeating means time period is 4 pi by 6, 4 units, 1, 2, 3, 4. So this point will come here, 1, 2, 3, 4. Next point, we have 1, 2, 3, 4. Next point, correct? So from here, 1, 2, 3, 4, and then there, right? So we get, do you see that? How easy it is. Similarly, we can draw the other points, 1, 2, 3, 4, right? So there it is going to end, 1, 2, 3, 4, right? So we can draw these points, 1, 2, 3, 4. So we get another set of points for us, right? Now this is from here, 1, 2, 3, 4. So I'm actually showing you exactly how we should be doing our job, right? So let me just draw this. Is it okay? So that is the function which we are saying is cos of 3x minus 5 pi by 6. And since the domain is all real numbers for cosine, it just goes on and on, right? So we got that part. Now we have to do reciprocal of this. Reciprocal really means that we'll have the vertical asymptotes wherever the function is 0, right? So the zeros are these. So we'll have vertical asymptotes here. So we have vertical asymptotes. I'm going down because I know we have to do minus 2. So ultimately everything is going to move down. So it's a good practice to straight away, when you make your vertical asymptotes, go till the lowermost point. Okay. I hope you are understanding what I'm trying to do here, and it really helps you to capture the steps which are required to sketch such a transformed reciprocal trigonometric function. Okay, so these become your vertical asymptotes. Now, secant really is reciprocal of this, right? So this part, reciprocal. That means when I am sketching it, I am using a lighter color at the moment. Reciprocal of 1 is 1, right? So, and then if the value is half, reciprocal will be 2. So I'm approximately, I'm not going to that accuracy. I'm just drawing like this, saying, well, it should be kind of like this, right? Now you can actually calculate the points and do more accurate things, but for me, I'm just doing it like this for the time being. Correct. So we got the reciprocal part of it, right? So obviously, if this point is 1/3, then that point should be 3, right? That is the whole idea, and this 3 is actually not here, but 1, 2, 3 is here. So it should have been there. So that is the point, right? So you could actually extend it kind of like this. Okay. So it's very steep, kind of like this. Right. Now, let us do the translation and this compression. So when I say times 2 over 3, then what is 2/3 of 1? 2/3 of 1 is 2 over 3. That means these points will come to 2/3. This is 2/3 for us. So all these points will come a lower level. Do you understand? Minus 1 times 2/3 will be minus 2/3. So they will come at this place. You agree with me? So basically, after I do 2/3, that vertical compression, these points should appear at this place. Correct? And second part to this is that I have to translate 2 units down. So if I do 2 units down, right, so 1, unit and then one more unit. So this point comes here. Do you see that? So that becomes your minimum point for this particular function. So all these points will be at minus 1, 1 over 3. Correct? That is where these points are going to be. So, as far as these points are concerned, I could sketch them finally as kind of like this. So that will also come to first the 2/3 and then bringing it to less, 2 down, 1 down and 2 down, correct? So we have something like this here. So that is what is happening to the upper part. Okay, so here we have the first part, then bringing it down, correct? So that is how we get 2/3 minus 2 for the upper half, and here 2/3 will be, instead of minus 1, it will be at minus 2 over 3, and then you bring it down by 2 units, right? So it is minus 1 times 2/3 will be minus 2 over 3. Then you bring down this by 2 units. So 1, 2, 3 is 1 unit. 1, 2, 3 is the other unit. So there you go, right? So this side of the graph will be, using the same color, will be kind of like this. Do you get the idea? So that is how the function is going to be. Right? No, not this part. So that is how the function is going to be. I hope that's clear to you, right? Not this part. Okay, so that is how the function is going to be, correct? Now as you can see here, what is going to be the domain range for this function? Can you write down? So you need to write domain and range of transformed function as an exercise, correct? So you can see from here that 0 and then they are repeating after 2 pi by 6, right? So the domain is that x belongs to real numbers where x is not equal to these positions, which is 0 and then 1 pi by 6, 2 pi by 6. 2 pi by 6 is pi by 3, right? 3 pi by 6, 4 pi by 6. 4 pi by 6 is 2 pi by 3, correct? So n pi by 3, where all these vertical asymptotes are at n pi by 3, I should write n belongs to integers, right? As far as the range is concerned, the range is that the values are y belongs to real numbers where y is greater than equal to minus 1, 1 over 3. And y is less than equal to minus 2, 2 over 3. So that is how you get domain and range for this function. And I hope the steps are clear. So when you are sketching reciprocal of a trigonometric function, sketch the cosine function first. All the x-intercepts of cosine function will give you vertical asymptotes. And ones and minus ones will be invariant points. As cosine function is between 1 and minus 1, secant will be greater than 1 or less than equal to minus 1. So you get the graph which I have shown you in green. And then you do vertical stretch by a factor of 2 over 3 and a translation by minus 2. 1 times 2 over 3 is 2 over 3, so that point comes here, the local minimum in this case, and then you translate it 2 units down to get the final result, which is shown here in this color. That is how you have to do it, right? And get your answer as we have done. I'd like you to watch this video once again, understand these steps, and then do similar questions to practice. Thank you and all the best.